Yo, what's up, Tech Tribe? It's Shuda, your friendly neighborhood IoT troublemaker. Today we are diving into ESPHome, the tool that lets you write firmware without burning your brain on C++, and YAML, the language that looks like you are writing a to-do list but your microcontroller actually listens to. So buckle up and let's get geeky and glorious. Spoiler alert, I was going to use my relay model for this demo, but let's keep that for another episode. For now, I'm keeping things simple, yes, simple and basic. Just me, my ESP32S3 and its onboard RGB LED. This setup is perfect for showing you the basics of ESPHome and YAML. So you might be asking, what is ESPHome and why should you care? So, imagine you have an ESP32 or an ESP8266 sitting just on your desk blinking at you asking for meaning in life. What if I told you that there was a tool that lets you give a purpose, like measuring temperature, running a pump, triggering a buzzer, or even spying on your cat's motion, like without a single line of C, like C, the one they use for Arduino. That's ESPHome. Think of it as like no TS firmware maker for IoT. And guess what? Like, it talks in YAML, a language so simple even your toaster could understand. That's how easy it is to get it up and running. So first of all, as usual, you need one of these, a microcontroller. So you can either use ESP8266, which I don't have, but this is a classic ESP32 and this is an ESP32S3. I'll link links for buying one of these in the video description. Then for this video we are using this particular one because it has an onboard RGB, and then this is going to be perfect for showcasing how to write code for this onboard RGB and controlling it using ESPHome and Home Assistant. Then you are going to need a USB cable, yes, a decent USB cable, one that supports data transfer, a laptop or a PC, and then simply Wi-Fi, because Wi-Fi has to communicate. They have to communicate over Wi-Fi so that you can get that kind of connection. Like, that's all IoT is actually about, Internet of Things. So you need an internet connection, and you are going to get that using your Wi-Fi. So computer, I'm going to show you the process of installing ESPHome. So basically, we just open our browser. We are going to install two things. We are downloading two things. I'll link them in the description. So let's just open our browser. And the first thing we are going to download is Python. So let's download Python. So Python download. We go to their official website and then click on download Python. So just like that, it's going to install Python. I've already installed Python on my laptop, so I don't have to do that again. The next thing you are going to want to download is Sublime Text. So we are going to download Sublime Text too. Sorry about that. Sublime Text, which is this one, Sublime Text, this one actually. And we go into their official website when we download for Windows, just as you see. As I said, I'll link them in the video description. So one thing to note is that when you're installing Python, you make sure that you install it and then you install to path. Add to path is very important. Check that box. It's going to be on the first page of the installation page. Check that box, install to path, or add to path is one of them. Yeah. So the next thing we are going to do right now is that we'll close our browser and we'll go create a new folder. So the folder I'm going to create is going to be, I'll name the folder, I'm going to name the folder tutorials. So this folder is where our YAML files are going to be stored. We have the tutorials folder created successfully. We are just going to copy as path. So we copy that as path, and then we open CMD, that's our command prompt, with the shortcut Windows key and R. Then just type in CMD. Then we should be good to go. Now we are going to type in a command called change directory. So change directory to the folder we just created, and then we are in. The next thing we are going to want to do is, for this step you have to make sure that Python was correctly installed. As I already said, it has to be correctly installed. Then we are going to type in a command called pip install ESPHome. So the pip here stands for Python install package. It's very important. That's what you use to install all these packages on your command prompt, and then type in.
So as you can see, mine didn't take a lot of time because I've already installed ESPHome on this laptop. But for those who are installing it freshly, it might take a little bit of time, but it's not really a lot of time like that. It's just take a few minutes. So now we are going to create our first YAML configuration file. So we are going to type in a command called ESPHome. First, you can also choose to confirm that ESPHome was successfully installed by typing in the command ESPHome version, and it should print out the version of ESPHome you have installed. So as I said, we are going to create our first config file, and for that we are going to type in ESPHome wizard, then the name of the config file, whatever you choose to name it. So for this one, since we are controlling an rgb.yaml, sorry about that, YAML, and then it will be created. So as you can see, hi there, I'm the wizard of ESPHome, and I'm here to help you get started with ESPHome. So you follow these 4 steps, and I'm going to show you how to. So the first step is the name of the node, or the name of whatever you are doing. So in our case, we are going to name it RGB. So you can just name it RGB, or let's just go with demo. Then we are in. So our node is called demo. What board are we using? We are using an ESP32. So now this is a very confusing part. Let me open it. So as you can see, there are a lot of boards listed here, a lot of ESP32 boards listed here. You have to find the particular one you are using, the particular board you are using. So in my case, I'm using an ESP32S3, and it's over here. So I'm just going to copy that. So Control C, and I'm going to paste it over here, and then there we go, we have it pasted. Now the next step is we are going to put in our Wi-Fi name. So for me, the Wi-Fi name is called Sese. So Sese, that's my Wi-Fi SSID as in the name of my Wi-Fi. Then my password. So the password I'm using on that router is 1228. So 1228.3320. And then we have it. So OTA, over the air. So over the air is for wireless firmware update. So after writing your firmware to your microcontroller, if you wanted to update it and you didn't necessarily want to use your USB cable, you can just use OTA or over the air. So we are just going to put a password for that because we have to protect it so that it's not everyone who has access to your Wi-Fi network that can access it. So for that, I'm just going to use the same password I used for my router. And then there we are. We successfully created our ESPHome config file. So we'll find it in the folder we created. So tutorials, and there it is. So we can open that now. So after opening that, I have a full, as you can see, created the name of our ESPHome node is demo. We are using an ESP32, so the type of board is listed here. Our framework is Arduino. Now password is set, OTA password set, Wi-Fi name is also set over here, and our password is over here. Now this demo fallback hotspot is for if there is no Wi-Fi connection. So in that case, your microcontroller is going to set up a Wi-Fi hotspot, and then your device can connect to it and still access the firmware or the microcontroller for your IoT purpose. So this is the code I wrote for this particular microcontroller. As you can see, it's the same framework I'm using over here, but I just added the code to control the RGB. So as I already said, writing YAML files is like writing a to-do list. What do we want to control? A light. What is the platform or library? NeoPixel bus. What type? GRB, which is also like RGB. This is just like green, red, blue, or RGB, anyhow you want to call it. The variant is WS2812, so it's a very popular type of LED addressable. Is a common type of addressable LED strip. So those LED strips that can be controlled using phones and everything, I think most of them use addressable RGB, and then this is one of the most common ones. Now pin. On my ESP32S3, which is this one over here, the pin that has been assigned to this particular GPIO is the pin that has been assigned to this particular RGB is pin 48. So for those who use normal boards and try to interface and the RGB strip to this, which is very possible, you make sure that the pin, or you check the data sheet or the input and output pin diagram, and make sure that your RGB is connected to the particular pin, and that's the pin you put in there. So for my case, it's connected to GPIO 48. So GPIO means like general input and output pin. Yeah. So general pin, input and output. So mine is GPIO 48, and then that's it. That's the whole thing. Then you can name the LED. So in your Home Assistant or wherever you want to access this, what do you want to call that RGB? So in my case, I want to call it an onboard RGB LED. I can rename it or anything, but in my case, I'm just doing that. So the next thing is that we are going to go back to CMD, and then we are going to flash this. So before that, you have to save. So after saving, that's always going to be saved to the folder we have it in. We go back to CMD, and then we are going to compile what we just did. So for the compilation process, we are going to run the whole YAML file. So ESPHome run, and then what we called our YAML file. So before that, let's just plug in our ESP32 into our laptop through USB data cable. So then we are going to type in the command here, ESPHome run rgb.yaml, and wait for that to compile. So yeah, the compilation process has started. It's going to compile and download all the necessary libraries, and then we are going to flash the firmware onto our microcontroller. So for this, you have to make sure that the necessary drivers for your microcontroller are installed. In my case, I use the CP210X drivers for my microcontroller. So there are plenty of resources on how to get those drivers installed on your laptop or your computer to get the ESP32 working with your laptop. So as we can see, we have two options here. The first option is USB enhanced serial, and the second option is over the air. So that's the OTA. That's if you want to do it wirelessly after you've connected it to an instance or something. So we are going to go with the first option, which is the USB option. And as we can see, the firmware is flashing, and then that can be indicated with this green LED that is flashing rapidly over here. So we can see our green LED flashing. Yeah, and then that's all. So yeah, as we can see, it has successfully been flashed. The firmware is successfully flashed onto this, and then with this, we should be able to control the RGB LED on this microcontroller. So that's what we are going to do next. So one thing to note is that for your microcontroller, yours might be different, but one thing to note is that if you are having problems flashing the firmware onto this, then you have to force it into boot mode. So to do that, you have to press on the boot button, long press on the boot button, and then choose the option 1 so that it flashes in boot mode. Once it starts flashing, you can remove your hand from there, and then you are good to go. So that's one thing you have to note.
So finally, as you guys can see, I have my Home Assistant server up and running over here. So basically, there's an old laptop I repurposed into a Home Assistant server. And then over here, as you guys can see, I've accessed my Home Assistant server. So this is called the Home Assistant instance. So I've accessed this over here. And what I can do from here is I can control the LED from here. Remember the one we programmed. So the onboard RGB LED. Toggle it on, and then I could go into its settings, which is over here. I don't know why that's taking some time. And then I can change the color to any color I want. I could change the color to any color I basically want, and then cycle through the colors. Over here too, as you can see, there are a lot of colors I can actually choose. Orange, purple, or is this pink? This is more of pink. This, I don't know what color actually this is. And then finally, brightness can also be controlled. So
33% brightness. This is 12% brightness. Can go all the way up to 100%, 50%. Let's go to 50. That's half of the brightness, and then there we go. So all this is controlled using my Home Assistant. You can actually host your server on Home Assistant's dedicated cloud service. So that's called Nabukasa. So it's a cloud-based subscription service where you pay, I think, $6 a month, and then you are getting your server hosted on dedicated servers outside. So on a normal, the Home Assistant is local, meaning it runs on your local network, no internet needed. So you can control anything, all your appliances without an internet connection. But what if you wanted to access your server from anywhere in the world, so that you could actually control all your devices from anywhere in the world? So that's where the cloud service actually comes in, and it's quite good. And then there is a way to get 1 month free. So basically you move over here to Home Assistant Cloud. Sorry about that. And then I've already signed in, but over here at the Nabukasa account, you are going to get an option to sign up and get 1 month free. You are not going to link any card or anything. It's just going to ask you for your email and password, and then you are in. That's basically everything. And now you might be asking, what are the benefits of having Nabukasa Cloud? So it opens a lot of possibilities. So with me having my server hosted on Nabukasa, I could use Alexa to control my devices. So moving on to the Alexa app, as we can see, the wake word was activated there. All my devices that I've actually gotten online, the microcontrollers that I've gotten online, are accessible here. So the one we configured was the onboard RGB LED, and then I can access it from here. I can turn it on using, and then I can turn it off. I could set the brightness from here to anything I want. Set it to a low brightness, set it to a high brightness. I can change the color from here to any color I want. So this is all using the Amazon Alexa app. And then voice commands. So we could use voice commands. So let's try using the voice commands. Alexa, turn on onboard RGB LED.
Okay.
Alexa, set the brightness to 50%.
Okay.
Alexa, set the color to blue. Alexa, set the color to yellow and set the brightness to 100%.
Okay.
Okay, it didn't quite understand the yellow part. Let's go with that again. Alexa, turn the color to yellow.
Okay.
So as you can see, it's working and everything. For a bonus, I have this ESP32 Classic hooked up to an LED. So basically this LED is running from the ESP32's 3.3 volt logic, and then the transistor here is what is driving the LED. So basically I could also access this using Alexa because I've linked it to the app. So I could turn it on. So turning that on, I could set the brightness to any brightness I want from the app. And then I could also use voice commands. Alexa, turn LED lights to 100%.
Okay.
Alexa, turn off LED light.
Okay.
So as you guys can see, everything is up and running, and then the network and then the stability of the server and the cloud servers are very good. So this is simply how to use ESPHome. It's quite effective, and then it's easy to do, and it's good because it runs both locally and then on the cloud, and then can be accessed using voice assistants like Alexa and then Google. So that's all for today, and I hope you guys have been able to get something from ESPHome. So a summary of what ESPHome is: so basically it helps us write firmware to our microcontrollers, and then we're able to control our devices using Home Assistant. Home Assistant is local and then can be accessed using cloud service, so making it versatile. And then, as I said, I am linking videos on how to install Home Assistant on any computer in the video description. So if you like content like this and you like to be updated on future contents, how to do things like this, how to interface microcontrollers to Home Assistant, writing codes for sensors and relays, almost everything, we are going to cover it on this YouTube channel. So I plead with you to actually like and subscribe so that you get updated on all my videos. Thank you and God bless you. Bye bye.